Hello students, welcome back. Today we'll be working on solving exponential equations with logarithms. So I want you to know a little bit about logarithms. First of all, a logarithm is an exponent. And whenever you have to solve an equation where the variable is the exponent, you can use a logarithm. So the way that you would say this statement is log base b of a equals x. That's how you would say that. And you would translate it. So the b is the base. So you would translate it to an exponential like this. The x, the part that the log equals, is the exponent. So logs equal exponents. And then what you're taking the log of, I call that the argument. That's what your base to the x power would equal. So we're going to do some practice today with, first of all, evaluating logarithms, and then second of all, solving some equations using a logarithm. So first of all, evaluating. One thing that I think will help you is to put your problem equal to x so that you can see an equal sign. And then the little number beside the g, that is your base. So the 5 is your base. So this number right here. The part that the logarithm equals is your exponent. So 5 to the x power equals, and then your other number, 625. And then we're going to solve this equation like we did in the previous day's lesson. So you may need your chart to look at, and I'll bring that up. So your base chart. So we had 5 and we had 625. So those are both in the 5 row, and 625 is 5 to the 4th power. So we'll work with 5 to the 4th power, changing that. Let me get my pen back. All right, so 5 to the x would equal, and then 625 is 5 to the 4th power. And so your bases are the same. We can cancel the bases, and your exponent x is 4. So let's kind of put this together then. Log base 5 of 625 is 4. So notice that the logarithm is equal to the exponent. All right, so let's try this again. Your second problem is log base 8 of 512. We'll say that equals x. So we're going to make the translation. The first thing to do is to find your base. So that is 8. I'm going to erase that circle so you can see it. Then your exponent, after the equal sign, that's your exponent. And then equals your argument 512. All right, so we'll go back to the base chart. We're going to look to see if 8 and 512 are in the same row. And they are. So 512 is 8 to the 3rd power. It's in that 3rd power row. So we'll go with 8 to the x equals, and then 512 becomes 8 to the third power, and we'll mark out the 8s and get x equals 3. So log base 8 of 512 equals 3. So our logarithm equaled our exponent. And then the last example like this that we're going to do is log base 2 of 1/16 equals x. All right, so our base is 2. Our exponent x equals 1/16. So going back to our base chart, we need the 2 row, and 1/16 is our base to the -4. So that's going to be 2 to the -4 power. So 2 to the x equals 2 to the -4 power. That's what 1/16 is. Bases are the same. We can cancel that out. And your x equals -4. So the log base 2 of 1/16 is equal to -4. So again, logarithms equal exponents. And we'll use a logarithm to solve exponential equations. And that's actually what we're going to start down here. So there are some logarithm or some exponential equations that cannot be converted to the same bases like we did in these first 3 problems. And that's where you have to use a logarithm. So we're going to convert from an exponential. So see that you have a base with an exponent equals an answer, to a logarithm in order to solve. So notice that the exponent is what we're solving for, and then your base is written in the lower part of the logarithm, and then the answer is what you're taking the log of. So here's an example. We have 2 to the x equal to 13. Well, so if I go to my base chart and look in the 2 row, 13 isn't on there. In fact, 13 is nowhere on this chart. So 13 is not a number that I can convert to a base. So instead, I'm going to convert it to a logarithm. So I'm going to have my exponent, that's what I'm solving for, x equals log. Now, my base is the 2, so base 2, and my answer is 13. So I'll try to color code those things where they came from. There's your exponent. Wait a minute. Your exponent I have in this color. And then didn't change colors for me. Your base is the 2. So once you get it to here, then you're going to use Desmos, and we're going to approximate this to 4 decimal places. So what we're going to be typing, okay, so my keyboard is here. Your functions are here. You want to go to miscellaneous, and right there is your log with the base. So you'll type in log. This part right here is looking for the base. It was base 2, and then the number that we were doing the log of was 13. And notice that it gives us this decimal. So 3.7004 is what we'll use. We're going to go to 4 decimal places. X equals, and we got 3.7004. So I just want to show you using Desmos what it is that you found when you did that logarithm. So the original problem was 2 to a power. So if we did 2 to this power of 3.700439718114, we would get that 13 that we were looking for. So this exponent with a base of 2 would give us the 13. And without a logarithm, we wouldn't be able to know what that is. And although this may not seem like it's very important now, there will be problems where you'll need to know an exponent like this with a base that you can't make the same on both sides. So let's do one last problem. We have 7 to the x power equals 15. If you look on your base chart, 15 is not in the 7 row, so we'll need to use a logarithm. So the first thing is that exponent, which is your x, equals log, and then your base is the 7. So the base is the 7. The argument, what you're going to take the log of, is 15. And so we'll have our exponent equals, and we're going to use the Desmos calculator. So log base 7. Again, if you missed how that happens, you get the keyboard, you go over to functions. Here's your different functions. You want to be on miscellaneous. Here's the log base A. So it'll take you to where you type in your base. That was the 7. And then what we were doing the log of was 15. And we have 1.3916. Now this 6 is going to round this one up to a 7. So 1.3917 is what we'll write for our answer. 1.3917. And again, that number, so if we would do 7 to that power, so if I use my exponent and then do 1.39166250994, I get 15. 7 to this power is equal to 15. So again, you're going to use a logarithm to solve for an exponent that is not able to be written using the same basis. So these problems were to get you used to what a logarithm is, and these problems are what logarithms are used for. So your homework will be on Math Excel, and good luck with your homework.